All right, it's 11 o'clock. Welcome everyone to our first bi-monthly diverse webinar. Before I introduce the series and our speaker, I just want to start with a land acknowledgement. The University of Alberta respectfully acknowledges that we are located on Treaty 6 territory, a traditional gathering place for diverse Indigenous peoples, including the Cree, Blackfoot, Métis, Nakota Sioux, Iroquois, Dene, Ojibwe, Saulteaux, Anishinaabe, Inuit, and many others whose histories, languages, and cultures continue to influence our vibrant community. So thanks so much for tuning in to our first of these seminars. The goal of these seminars is to engage with our partners and hear more about not only what is happening with the Diverse project, but also hear from our collaborators on what they're already working on. During the presentation, feel free to submit your questions in the Q&A at the bottom little banner of your screen. And you can also upvote questions that other people have submitted that you also think are of interest to kind of show us that that's of more priority that we should address. We'll leave time at the end of the talk for a response to these questions. So I'd like to now introduce our speaker for today's presentation. Dr. Christian Messier is a prominent figure in the field of biological sciences, particularly in the area of forest ecology, and he is the principal investigator for the DIVERSE project. He's been a professor at the Université de Québec Montréal since 1991 and is also at UCO. He's known for his work on the dynamics of forest regeneration following the cutting of old growth forests, and he'll be sharing with us a bit today about the DIVERSE project. So Christian, go ahead and share your screen and turn on your camera and take it away.
Thank you very much, Catherine. Hello, everybody. Can you see my screen? Let's put it full. Perfect. So, yeah, it's a pleasure for me to actually give this presentation. I've given this presentation many times, and I saw that you have listened to this presentation many times before. But just to tell you, I have a few new slides, so I think you might actually get something new from this presentation. So the first slide, as you see, is the title with all of the partners. So this is really a big effort with partners across Canada from different organizations, from First Nations, from different forest industry, from different non-government agencies, and with lots of partners from almost all universities in Canada, and also from various partners from all over the world. So DIVERSE, adapter les forêts aux changements globaux en français, is really a big project that is actually trying to look at how we could transform the way we do forestry across Canada to achieve many things. Here you see a picture of the 22 sites that we will be testing across Canada. So from different regions, different biomes, even some public, private forests, some forests managed by Indigenous nations. So this is a very big undertaking. And basically, what we see as value in this project for the partners is really to try to increase the resilience and better adapt our forests to the global change so that we can continue rely on the many very important ecosystem services that we rely on. We see that as a way to redefine how forestry is perceived by the public. I think if we do it well, forestry could be a major force to increase the resilience and the adaptability of our forest. So we'll be testing different approach to do this, and we will be using various tools to assess what are the major threats in the future and what we can do to actually increase adaptability and resilience. And of course, we'll also learn to navigate better the very large social and environmental uncertainties of the future. Maybe this is one of the biggest challenges we are facing today is the uncertainties. And there are ways, there are approaches to deal with uncertainties so that we can still make decisions and hope that our management will be doing well in the future. So the value for the managers in the forest will be to have different tools and different approach and they will be able to determine what different forest management are likely to do in the future according to their local environment and their local conditions. Of course, we want to maintain and improve the resiliency of the forest, so we will test different silvicultural treatment, and we really want to do this through this functional complex network that I will explain to you a bit later on. So this is the some of the main individual here. You have the research project leadership. So 4 of us, 2 at the University of Alberta, and myself at UCO, and Alain Cassie, plus a very good and very dynamic support staff, Hélène Marchand, Eastern Coordinator, Catherine Norel, that you just heard from the Western part of this project, Clément Hardy, who will be actually a technical assistant with Landis, which is our model we'll use, but also will help with the communication aspect. And Kim Bannon will be the administrative assistant trying to deal with all of the complexity of this project. And of course, there will be lots of national and international collaborators, various researchers, professors from different fields. And we will actually get 28 graduate students over the next 5 years to do the work. And of course, when we talk about a big project like that, we need money. So we were able to secure 7.4, a bit more than $7.4 million over 5 years through this NSERC Alliance grant that is divided with around $2 million coming from the different partners, 1.4 from MyTax, which is a program that really encourage graduate students to work closely with partners, and then NSERCs provide the other $4 million. So that gives us quite a bit of money to try to do these different things that we want to do. So the project, the DIVERSE project, is divided into 6 themes, and I will go through them slowly so that you understand that these themes are actually well integrated and that they support each other. So the first theme, which is actually something we've already started to do, is to really evaluate across Canada, across these 22 sites, what is the resilience and the vulnerability that we find across these 22 sites. So how vulnerable are our forests to climate change, to the different pests and diseases that are increasing? And what is the current resilience of these forests to these threats? And in a way, this will set the basis so that we could actually determine, do we have the right suite of tree species in different parts of Canada to face these new challenges? So we will identify what are the tree species that are needed to face these challenges, and even identify maybe some new provenance or even new species that we probably will need to migrate from different regions to new regions so that the forest will be better adapted to the future conditions. Then we will develop and further enhance this functional complex network. So I will explain a bit later this functional complex network, but this is a way to determine where on the landscape we should intervene first to make our intervention in terms of increasing resilience as efficient as possible. Because as you all know, we are guardians of a large forest, and it's impossible to intervene everywhere. So I think if we use this network properly, we'll be able to determine where we could intervene to have the most impact. And a lot of this will be supported by simulation. We will simulate various forest management strategies. The statu quo that we often call it, it means that the current forest management that we do, but then we'll test all kind of scenarios. Working very closely with the partners, we will determine what are the best scenarios we want to simulate. And then we'll simulate different scenarios of climate change and different scenarios of disturbances, and really test if we could maybe modify our practices, increase functional diversity, bring new species so that we improve the resilience and adaptability of our forest. Of course, I've been talking a lot about the biology side of things, but the socioeconomic factors are very important. I think we need to determine what will be the cost and probably the benefit of doing this approach. But also we need to look at social acceptability. We need to look at what are the rules, the regulations that are in place that need to be changed if we want to implement this, so that even if we find some approach that are working, we have to determine and work closely to make sure that they are economical and socially acceptable, and that the rules that are currently in place will not impede the development of these new practices. And then the last theme is a foot in the ground. We really want to start in the next 5 years, setting experiment across Canada to test these new approach, because I think it's good to do the science, to do the theory, to do the simulations, but we need to test it, have demonstration areas. And one of the objectives of this Theme 6 is that maybe after 5 years, we'll renew this project and really push for a further demonstration and further testing of this approach across the whole country. So each team has a leader, and you can see the name of the leaders from different parts of Canada, from different organizations. And I think they will be in charge of making sure that within each team, the work is done properly. We will have lots of meetings across teams to make sure that the science is done not just in silos within a team, but across teams, so that everybody benefit and everybody knows what's happening. So this is the strategy of this project and what we intend to do in the next 5 years. So I actually started this maybe I will not say backward, but in a different order. Usually I finish with the diverse and then I talk about why we need this project. But I wanted this time to talk about the project and then explain to you why we need a new way to do forestry, why we need to increase the resilience and adaptability of our forest, and maybe share with you some of the science that has been done that has been helping us develop this strategy. So I start with this slide, uncertain and threatening future. And as you know, especially in Canada, we've had this incredible fire season last year, and I think we will have more of it, and we'll have also other disturbance. If you live in Eastern Canada, you know that we tend to lose a tree species every 5 and 10 years to new bugs or a new disease. So this is happening actually across the world, and in the magazine Science a few years ago, on the cover, they talk about forest death because they have received so many papers, published so many papers about how the forest is being threatened by climate change and other biotic disturbances, so that they felt that it was something they needed to do. Just to go through some of the threats, exotic insects and pests. I used this paper from 2016 from Lovett and many other collaborators, which list all of the non-native forest insect and pathogens that are currently in the United States and currently having an impact and affecting the way they do forestry. And what is important is that these insects and disease, I look at them, there's around 25 that will move, are starting to be present in Canada. And I even listed that there might be up to 33 species that might be strongly affected in the next 50 years. And the slide shows why we have such a problem with exotic insects and disease, especially in Eastern Canada. If you look here in Eastern Canada, the problem is that we do a lot of trade with Europe, a lot of trade with Asia, It all comes to Eastern Canada in the US and Canada. And because we share the same biomes as Northern China and most of Europe, the risk that there is an insect disease arriving in North America and affecting our trees is very high and even increasing. And so we should expect in the next 30 and 40 years, unfortunately, more and more of these disease and insect affecting more and more tree species. Of course, climate change, we all know, we've heard about it. And you know that the way we look at it is looking at different scenarios. The most optimistic scenarios, what we call the SSP 1.9, is a scenarios where today we will take very drastic measures so that we decrease our output of CO2. This is a very unlikely scenario because we are not going in that direction at all. And then there is the worst scenario, the SSP5 or 8.5, which is a scenario where we continue on the same trajectory as we have today, and we will continue to that for another 100 years. And you can see that the increase in temperature and the impact will be quite large. Most people now think that we will probably reach a compromise in between, but the problem is we don't know. So there's quite a bit of uncertainty, and we need to deal today, making decisions today based on the fact that we don't know if it will be 1 degree, 3 degree, 5 degree, or even maybe 6, 7 degree in the north in Canada, warmer than it is today. And there's already a signal in the forest. This paper published a few years ago that looked at permanent plots and was able to tease out the mortality that was measured in these permanent plots due to drought. And here are some graphs. Since the 1960s, there's a signal in the forest. There's more and more mortality in all the regions, in all the species that were measured there, all diameters, all elevations. So there's really a signal. Mortality is increasing. This is only due to drought, according to the approach they took. But if you add extreme temperature, insects and disease, and fires, and wind, I think we can say that there's more and more mortality in our forests, and this is actually quite important. And this is actually happening all over the world. There is this former PhD of mine, Henrik Hartmann. He's in Germany now, leading a big network across the world, looking at climate change and increase in mortality. So he has published these papers that show that there are signals all over the world of increased tree mortality due to drought and heat, and this is increasing. So more and more of our tree species are experiencing climate that they've never experienced before. They are getting stressed. Maybe the heat or the drought is not killing the species. Maybe it's an insect that they used to be able to fight that they cannot fight, but the signal is there, very strong. There's more and more trees dying in the forest, and I'm sure that you've observed that in the forest that you manage across the country. And actually in Europe, they did something that I think is interesting, is they look at the increase in natural disturbance in Europe since the 1950s. And the slides here shows that if you look at these different disturbance, wind, abiotic fire, or bark beetles, since the 1950s, they see a very, maybe not as strong, but a continuous increase in disturbance with, of course, years where there is big disturbance, like just before the year 2000, there was a big wind event. This doesn't cover the big drought event that occurred a few years ago in Europe, where in Central Europe, a lot of trees died. So, but the signal is very strong. And I think if we were doing something similar in North America, we'll see the same signal. So some researchers have simulated or looked at what is likely to happen in the different continents in the world in terms of the main disturbances that are likely to increase. So what is in pink is disturbances that are likely to increase. And if you look at North America, the main disturbance here, fire, drought, insects, and pathogens are likely to increase quite a bit, which is very similar to the situation in Europe, but different from other continents. Like in Africa, I think that we expect more drought, more fire, but not too much problem with exotic pathogen and pests, and it varies from different regions. But here, we are the unlucky ones. Maybe with Europe, we tend to have many more factors that are likely to hit and affect negatively our forests. So the paper concluded that we need to adapt to these increasing disturbances in our society, but also in our natural system. And I think this is something that this project DIVERSE is trying to do. What should we do? What can we do when we manage these forests to make them more resilient, better adapt to these increasing threats in the future? So although the project has just been announced and launched recently, we started to work on this many months ago. I've had some postdoc working with me. Morgan, I think I saw that you were listening to this. But we did some work, and what we did is we look at what we call the safety margin, the climatic safety margin, looking at some predictions of climate. And here we use the SSP3, which is kind of a, middle of the road scenario for the future. And we divided the country into these different areas where we look at all the species that was present, simulated what will be the climate in the future, look at what was the normal climate zone in which these species normally function. And here what we show is the percentage of species that exceed for each of these different climatic variables, that when they exceed what we call the safety margin. So they are outside the range that they have evolved to grow and to cope with. So for example, the mean average temperature, you can see that in most of the north, we are in the yellow. So there's not too many species that will be experiencing maybe climate that are outside their safety margin. But in the west and in the southern part of Quebec and Ontario, there will be more. Maybe the worst situation is with the maximum temperature of the warmest month. And actually, today is a good day to talk about it because we are experiencing in Eastern Canada quite a big temperature. We had 35 degrees in Montreal, for example, yesterday. So what this shows is that in many parts of Canada, the species that are there today will be experiencing in the future, or they will be outside their safety margin. So 80 to 100% of them in many places in Canada. And it doesn't mean that this will kill them, but it will be a stress that may actually make them more susceptible to other stress, insects, disease, maybe a colder winter, etc. So this will be all stress that will add up. So these are one of the first things that we did that will help us determine the vulnerability of our forest, as I mentioned in the theme 1. And based on this, we'll be able to make some recommendation about what new species should maybe be favored, planted, so that we increase the resilience and adaptability of our forest. This is a new report that was done in the last 3 years. We asked many of you and many foresters across the world how they felt about forestry in the face of global change. So we did a survey, and you can see that we surveyed a lot of people in North America, but we surveyed people from all over the world. And I don't want to talk too much about it, but I just wanted to show you that depending on the type of disturbance that we were talking about, most foresters were actually quite negative. They had a negative outlook in terms of biotic, climatic disturbance, even the social aspect. So the view is that the future will be more difficult than today, and that we will need to adjust so that we may continue to benefit from our forests. So this is the part that is a bit different from my previous talk. What I did in the last 2 weeks, I kind of searched the literature about some relevant recent papers that might help us and maybe guide us in the future for this diverse project. And some of them are actually positive. Many of them are maybe not so positive, but I took some and I thought I will share that with you. This is a very recent paper, 2024. This is a paper written by, I think, a postdoc, but also with Cindy Prescott, which is a retired professor from UBC, about assisted migration. And what they did is they reviewed papers and they reviewed the literature, and what they found was that 60% of the reviewed paper express a positive attitude toward assisted migration. So a lot of the science that is being done tend to show that it may have some benefit for our forest. 1/5 of the paper also emphasized that it could enhance adaptation to our forest. So this is something that is interesting. A lot of them were supporting assisted migration to increase production in terms of timber, but also to reduce risk of losing forest or losing key type of species. But there is also, and I think we have to be very well aware that there is risk and there is concern about risk of invasions when we introduce species, risk of maladaptation, and even some concern, I will say ethical or moral concern about, is it right for us humans to play with nature and move species around? You all know about this, but this is present in the literature. So they concluded that we need a more holistic approach, and they provide some guidance. I think it's a nice paper to read. And I added also that one thing that they haven't talked about, but I think one risk that we need to look at when we test assisted migration is how it will affect the functioning of the ecosystem, how it will affect the soil, the biodiversity in the soil, the biodiversity in our different species. Will the different species that are growing there adapt to these new species? I think this is something that we will need to do also. So another paper that is also quite recent, published in PNIS. For those who don't know PNIS, it's a very prestigious journals. Different people, Loic d'Orangeville, that I know is a professor in maritime. And here they were kind of positive. They were saying that they see that with warming, there will be a large positive effect in terms of tree growth. And they even expected a 20 to 23% gain in growth with these two different scenarios that you see here that are quite extremes in terms of climate change. So that they were even looking at the whole of Canada, and they found that in the colder and wetter region of the world forest, there might be a significant gain. And this is interesting because in the coldest and wetter region of Canada, sometimes the soil is too wet for the growth of the trees, so that sometimes it may actually, the warming could actually improve these conditions. So here's a map, and you can see where there will be the most, the situation might improve the most. It's mainly in the east, as the darker blue is increase in growth, and the yellow is even a decrease in growth. So the west will benefit much less than the east. And here you have the different species. For example, here BS, I think, was black spruce will tend to benefit in the north, whereas black spruce more in the maritime will benefit a bit less. Maybe jack pine will benefit. Anyway, an interesting paper that look at some of the potential benefit, and they say that this could actually compensate some of the loss from other disturbances. Another paper that is not yet published officially, it's what in the stage of what we call a preprint. It's getting more popular now. The researchers are publishing their paper before it's being evaluated. So this one was trying to look at this effect of warming due to climate and the increased disturbance that are most likely to occur with climate change. And they actually have similar conclusion as the previous paper. They said if we look only at warming, there might be a shift toward more dense forest landscape. More dense means more growth, more trees. But with more intense disturbance, we will tend to see a reduce in tree cover, so that will favor more shrubs and more grass. We may even lose some forest. And then when we look at the interaction between these two, warmer and more disturbance, they were seeing an expansion in the deciduous trees. So this will favor in the boreal forest, the aspen, the birch over the conifers. And this will have other impact. For example, the warming, which increased growth with increased density of the trees, will tend to decrease the albedo because conifers tend to absorb light, so the albedo decreases. But with the increased disturbance, it will have the opposite effect, because if we get more deciduous in the winter, they drop their leaves, and so the white snow underneath will reflect more energy, so that there is some gain and loss. And of course, what they show, and this was a simulation model that they use, they show that there is quite a bit of uncertainty. And again, we'll have to deal with this uncertainty when we manage our forest. Just one graph that look at albedo. Here's the albedo. When it's positive, it means that there is actually more light being reflected, so it's actually cooling the temperature. Here, this is due to the increase in deciduous. And here, when you look at only warming of the climate, the blue line, where you get more dense conifer, then the albedo will decrease, and it will actually warm the atmosphere because it absorbs the temperature. So these are interesting results. Another one just published recently about resilience and vulnerability. I thought I will show it to you because this is theme 1, and I think this paper was interesting in saying that these are very important concepts that we need to understand them well. They even show that there was some confusion in these two concepts, that we need to be aware of it, and that these two are actually complementary. So we need to work together. That's why we have team 1 looking at both of them. And I don't want to go too much in the details, but some of them deal more, like resilience, deal more with the temporal response to disturbance, whereas vulnerability is more of a spatial analysis of where we have problems and where we need to maybe increase resilience. And they show these very nice figures that show how they are linked and how they are different, and how when we work with these two different concepts, if we are well aware what are their strengths, their weaknesses, and how they can work together, I think we can use them to make some very strong inferences and really help the way we manage our forest. So this is an interesting also paper in MBO. This is from a group more in Northern Europe, and shaping and enhancing resilient forests for a resilient society. I like it for many reasons. I mean, the paper was nicely written, but I like it because it really focused on the fact that one of the key aspects is functional diversity. So maybe to show you that this is not just here that we talk about this. This is something that is being talked all over the world, that functional diversity is key and is a very powerful approach to increase the resilience of our forests. Paper in Nature Communication about fragmentation. So you may wonder why I took this, because I thought it was interesting that they look at the whole world and they concluded that the tropic, the forest landscape was relatively intact, but this is where there was the most severe fragmentation. But they had a positive message. They have shown that in the last 20 years, fragmentation has decreased in 75% of the world. And when they showed the map here, what was interesting is the green is when fragmentation decreases, and the red is where it increases. And you can see in the world where we tend to have more fragmentation increasing in the Amazon, in parts of Asia, in part of Africa, even in part of Eastern Canada here and Western Canada. But globally, if we look at Canada, there was, it seems, a signal of decreasing fragmentation. So I thought this was interesting and maybe a good news. And I think we need good news, because we have so many, we're facing so many challenges that I think when we have good news, we should pick it up. And this is another one, research that I think is interesting. They look globally, what will be the impact if tomorrow we stop doing any management in our forests? Because, you know, a lot of people are promoting that if we stop doing forest management, the forest will grow, produce more biomass, fix a lot of carbon, and this will be very beneficial. And there's a lot of approaches in the world to do this, to encourage maybe conservation, to increase carbon in the forest. So they say this needed more research because it has been poorly quantified. So they use some simulation, machine learning, looking at all the data they could find all over the world, and they found that if we stop tomorrow morning any human management, there will be an increase in above ground biomass, but that this increase will be maximum 15 to 60% of the current level. And they even calculate that this will equate 4 years of the current production of CO2, so that they concluded that we could not upset the current trend just by stopping cutting the forest, because we will just slow it down a little bit, and that we really need to work very hard on the reduction of emission. But they produce a map of the world here where the impact of stopping cutting will have the most impact, and it was in Brazil, the United States, China. But of course, you are probably interested to know what was the simulation in Canada. And you see in Canada, the more kind of orange, the less impact it has. The more impact it has, but it has actually almost no orange, even some purple. So basically in Canada, even if we stop doing forestry, it will not increase the biomass of our forests very much. And I thought this was an interesting conclusion, and maybe should be discussed more, because in fact, if we do forestry management well, to use it to improve the diversity and the adaptability of our tree species, it could actually be beneficial in terms of carbon, because we will reduce mortality in the future. And here it shows that just by putting forest aside, it might not have a big impact in Canada. In some other part of the world, it might have more impact. This other paper was very scary, that there are more than 17,000 tree species at risk from global change, knowing that in the world there's around 60,000 tree species. This is quite a bit. This is almost a third of the species that might be threatened. Maybe the good news was that in Canada, there was actually very little, very, very little. The gray means not a big risk. Of course, we have less species, but even with less species, we have a low risk. And here were the different factors that could affect the loss of species. And in Canada, the only thing that came out was climate change. So with climate change, there was a risk of maybe losing one or two species that might be eliminated by climate change. But overall, the problem, as you can imagine, are more into the Amazon and the tropics, where there are many more species, and it's not mainly due to climate change, but to a lot of other factors that are often related to human expansion or use of the land. All right, so this was my little overview of recent papers. So I want to go back to the approach that we will be testing in the DIVERSE. And this is really an approach, as I mentioned, to increase resilience and adaptability of our forests. And a few concepts that I think are very important when we are going into that direction is this concept of novel ecosystem or novel system. And basically what we need to realize that today and in the future, because the environmental conditions are changing more and more, and because the biotic composition of our system are being changing a lot. I even heard a few weeks ago at a biodiversity conference that in some parts of southern Quebec and Ontario, we could expect that up to 80% of our species in our natural system might change in the next 100 years, because there will be migration, there will be new species moving in. So big change in the system, which means that when we plan forestry operation in our forest, we should not just look in the past of what worked in the past and what will be the impact that we want, but also look at the future that would be very different with very uncertain conditions. And I think this concept of novel ecosystem is very important. And this paper about post-disturbance reorganization of forest ecosystem that I always present, it's quite recent, and I think it's very important. And if I explain this graphic here, these are the 4 different ways the forest could reorganize itself following disturbance. It could be resilient. It means resilient in the traditional way. It may be affected, but come back to the same structure and composition as before. It could change composition, so there could be a new species coming in because conditions have changed and there's new species that might be better adapted to these new conditions. It may restructure, keep the same composition, but the structure will change, or there could be a total replacement of both species and a total restructuring, but maintain the main function of what we expect from a forest. And what this paper was showing is that it's during the, after a disturbance, either a natural disturbance or a cut, when a mature forest is being reorganized or is going through this reorganization phase, this is where we could intervene. And this is what this project DIVERSE is about. What do we do following natural disturbance or following forest management cutting, so that we could make sure that the forest will reorganize in a way to maintain the important functions that are necessary for our life in terms of carbon fixation, water filtration, biomass production, wood production, habitat for biodiversity. And the idea is that we could intervene then to make sure that the forest will be more resilient and better adapted. And if we don't, we risk in some cases, due to all the things I mentioned before, we risk to have some collapse and lose this very important function that we rely on in the forest. So we may have these kind of shrubby ecosystem, more open forests that will not provide the same kind of habitats for biodiversity and many of the services. So that this concept is very interesting. And a lot of divers will be looking at different systems saying, is the forest diversified enough? Does it has all the species it has to be resilient, so be able to absorb disturbances and come back? Or do we need to introduce new species to allow this reassembly or this replacement? I mean, these are the decisions we'll have to make to see if we could help or need to help the forest to get reorganized. I look at time. I'll go a bit more quickly. I won't talk about the portfolio effect, but just to tell you that there's been lots of paper recently about the diversity and the importance of diversity in making resilience. So if you look at the literature, you will see a lot of research, and I think a lot of research, not just in the forest, in the ocean, in the lakes, in the prairies, shows that diversity, having a diverse system is our best best approach to maintain an ecosystem that is resilient and able to adapt. So the solution we want to test is how could we help the forest to diversify in a smart and effective way so that every time we intervene in the forest, we actually can make decisions that will help the forest to adapt, not just at the stand level, but at the landscape level. So this is the complex, the functional complex network approach. This is a paper I wrote with many colleagues in 2019. We tested it in many areas in Eastern Canada so that we felt that this approach was actually working and ready to be tested across the whole country. So this is what the divers will be doing. And just a few concepts so that you understand what we're doing. Functional diversity, I've been mentioning it quite a bit. It's a concept that is it's very, very, how can I say, it's very important in science that has been developing in all fields in ecology in the last 20 years. But it's a new way to look at diversity. It doesn't look at species diversity or genetic diversity, but at how different species act in the ecosystem and how they react to disturbances. For example, how can different species reduce the risk of fire? We know deciduous species tend to burn less than conifers, so one of the traits is this ability to burn. So this is how they act in the system, or how they react to disturbance. So by tolerating drought, some species have deep roots or can close their stomata and survive, so they can react differently. And it's this diversity of traits that make species act differently or react differently that is actually something that we need to understand and know in our tree species to better make decisions in the forest so that we create forests that are more resilient and better able to adapt to the uncertainty of the future. For example, we are working a lot on using different traits that relate to these functions. And so we can characterize different species and put them into different groups. We call it functional groups, because if you put different species in different function groups, it's actually easier to manage. We could actually propose that in a certain region, under certain conditions, you need species from 2 or 3 different functional groups to make sure that this system will be able to respond positively to almost any disturbances. And just so that you understand the difference between functional diversity and maybe species diversity, for example, you could have a forest with 3 species from the same functional group. You have group 1, group 5, and here I don't see it, but it's group 2, okay? And if you calculate the functional diversity of this group, segment. Yeah, if you look at the functional diversity of these groups, because they have very similar traits, you will see that the functional diversity could be quite low. You have 3 species, but they have similar function. And if you compare now across functional group, if you have a forest with 3 species across functional group and you calculate the functional diversity, you will see that the functional diversity is much higher. So this is a very interesting, very powerful approach to characterize different forests to determine are there traits that are missing, traits that could make this forest more resilient to a disturbance or even reduce a disturbance higher, for example. And when we know this, we can then make better decisions to manage the forest to really increase its resilience and adaptability in the future. Okay, I won't talk about this. I wanted to talk about this other very important concept of trait connectivity and stand centrality. I mentioned that at the beginning that we'll be talking about functional connectivity. Those of you who have maybe worked more with animals, you know functional connectivity is how a landscape can be connected to allow the movement of birds or different mammals. But here I have adapted it to functional connectivity of trees in terms of how the propagules, the seeds can disperse and move from one stand to the other. So if one stand is disturbed and does not have species able to cope with the disturbance, if there are seeds or trees around that can cope with this disturbance, they might spread and we will have a forest that will regenerate and maintain its function. So this is what we call functional connectivity. And the other concept that is very important when we deal with these complex networks is centrality. Centrality is a way to determine what are the stands or the nodes in this system that are the most central. As you see here, these are very central nodes. And if we can determine what are these central nodes in our forest in terms of functional connectivity and functional diversity, they can help us determine where we could intervene in the most efficient way to have as much influence in the system as possible. So this is the concept of centrality. And I will end my presentation by a little, very simple illustration of these different concepts. Let's say this is one of the 22 units that we will be managing over the next 5 years and looking at to make it more resilient. Let's say this is one of the units. The first thing we will do is we will calculate functional diversity of each stand. So as you see, each area here is a stand, and each color is an indication of the diversity. So very light green is weak functional diversity, and a very dark green is strong functional diversity because it has more species with different traits. The other things we'll be looking is at the functional connectivity, and this is represented by the arrows here. So when there is link between the two, it means that the seeds from these trees can spread to another stand. And when the arrow is very thin, it means there's not many traits that could be spread from one stand to the other, the traits that the seed carries. For example, here there's many traits. So there's many species with different traits that could be moved from one stand to the other. So by doing this, we can characterize an indices of functional diversity that you see here, like 2.7, or an indices of functional connectivity, like 1.8. And then knowing this and calculating what is the functional groups that are missing in your forest, and then determining what are the central stands. Here I indicate with the yellow arrows 3 stands that are very central. If we go and intervene either by silvicultural treatment that will increase some rare species with some very specific trait, or by putting new species with traits that were missing but that are considered important for the future disturbances, we could very efficiently, by intervening only in 3 stands, increase functional diversity, but mainly connectivity. And you can see here the increase in red arrows, it's the increase in connectivity. So it means that by enriching a few stands, we are actually intervening and having a bigger impact in the landscape, because if a stand, adjacent stand is disturbed, there will be seeds from new species better adapted to this disturbance to be able to regenerate the forest. So I often talk about a way to vaccinate our forest against climate change by really targeting efficient intervention on the landscape that will have the most impact. So that's my presentation. So I end this there. And I think if there is question, we have a bit of time for questions.
Yes, and if anyone, thank you, Christian, for the great presentation. If anyone wants to, you can raise your hand too, and I'll monitor. I should be able to allow you to say that virtually. Oh, yeah, I already see a hand. Andy, go ahead and you should be able to talk now.
Andy.
Hello, bonjour Christian.
How are you, Andy?
Je suis ici dans la belle Provence.
Parfait. We should
All
meet.
right. Okay. Just a couple of quick comments, really. One is that a lot of research has shown that local events, local microclimatic effects at stand level tend to swamp any larger scale climatic effects in the short term. There's quite a few papers showing like local soils, local microenvironments, etc. Often have a very strong effect on seedling growth, etc. So I hope you'll be allowing for that as a covariate. And the other point is, I think the impression I've got after looking at this climate adaptation subject for a few years is that trees are quite resilient to a lot of climatic, a lot of long run climatic averages, but it's the extreme events that tend to take them out, right? Extreme drought events, etc., etc. And at the margins, at range margins, it's those cusp seasons, those freeze-thaw events, for example, that are particularly damaging to some trees. And so, at least in the medium term, you know, it's those cusp seasons. If you migrate a tree through several degrees of latitude, it's going to be those cusp seasons that tend to expose it to the most risk. So I'm sorry, that wasn't really a question, more of a comment.
No, but I will answer to your 2 comments. Of your first one, of course, the local conditions are very important when we do any management or any planting, and I think we cannot plant any species anywhere. We have to know the soil, we have to know the conditions, and I think this is very important, and you're very right about this. The second point, I'm not sure how to respond to it, but you're very right. Usually, I mean, trees are rarely killed by one disturbance, except maybe when it's an exotic pest and insect that could really kill it. It's the succession of stresses that will have an impact. And the more we will have climate that are outside their kind of natural range, they will tend to be getting weaker and more susceptible to maybe a drier year or a wetter year or even a colder year. So I think you're right there. And I think that's why we could actually improve the adaptability of our forests by moving some species and maybe making them better adapted so that they will be less affected by these stresses. But thank you, Andy, and we should meet and maybe talk more about these ideas.
Yeah, because we're local.
That's right.
I have another question here that just popped up on the Q&A, so I'll just read it out to you, Christian. This is from Nicole from West Fraser. There will probably be some species that have more desirable traits for projected future conditions, and presumably also species that are expected to not fare well in the future. Are we going to abandon those poorer performing species and put more priority on the better performers? Or will the intent be to subsidize and carry those poor performers in adding species diversity to the sites?
Well, this will be one of the objectives of this project, to discuss these things and decide what we do. But as I mentioned, we will not be able to intervene everywhere in the next 30 years. So even those less desirable species, which maybe have traits that are less desirable, will still be in the landscape. And I think we will not be able to eliminate all of them. But when we manage the forest, when we intervene, I think we will have to make some very hard decision. Yes, maybe we will need to abandon some species that we feel are not the best species. And I will give you an example that I give many times, but I was in the Gaspésie area in Quebec. And in the last 30, 40 years, the main species that was planted was a white spruce. There was a demand. It was a species that was well adapted there. But now most climatic conditions or predictions show that this species will not do very well in the future. And it means that we need to change totally our strategy. So maybe to not plant white spruce, or only on some sites where it has the better chance, and really move into other species. And I think these will be the type of recommendations that we will make all across Canada over the next 5 years.
Okay, it doesn't look like we have any more questions, and we're right at the end of our time anyway, so that works out perfect.
Exactly.
So thanks again very much, Christian, for presenting and kicking us off on our first one. And yeah, stay tuned, everyone. We'll be taking a break for the summer, and then our next seminar will be in September. We're still lining up our speakers, so stay tuned for that. We'll be contacting you with the information for that. And I don't know if everyone saw in the Q&A, but there will be a recording of this seminar that you can view afterwards that we'll send out soon. So yeah, thank you everyone for joining us, and have a great rest of your day.
And thank you, Catherine.
My
Bye-bye.
pleasure. Bye.